Okay, so now let's look at capital rationing and NPV. So as mentioned previously, NPV can misrank projects when capital rationing constraints exist. So in other words, the highest NPV project is not always the best project to invest when capital rationing is the issue. Okay? And we kind of explored, if you recall, that we talked about the problems NPV here, right? So we're talking about does not one can capital rationing constraints are in place. So that's what we're referring to. Okay? So basically in order to actually resolve this issue, we use the solver function. Okay, so let's look at example number 5. Okay, so what happens? Imperial Systems has $1 million available for capital investment during the current year. A list of possible investment projects together their net investment NPVs are provided in the next slide. So what we have is projects A to H. Okay, so assuming that it's not possible to invest in part of a project, you can't invest in 30% or 40% of a project. Which project should Imperial invest into or in order to maximize overall NPV? Now, so what actually happens here is that so if $1 million, okay, and we have net investment of age 200,000, 500, 275, with the NPVs of all these different projects, how much net present value is, and so on and so forth. Okay, so what we actually need to do here, okay, is that if the projects are ranked by NPV, then it would make sense that we should invest in C, right? And then B, and then A. So with a combined NPV of 191, as we can see, if we sum all of the above, it's 121, right? Because we talk about the fact that over here we have $1 million available. So basically, if we actually invested into A, B, and C, that would be 975,000. The most positive NPV are these three. We have an NPV of 121. Right? So we can't invest in G and E because we have capital constraints, because once we've invested in these three, we only have $25,000 left, so we can't invest in the other ones like F, G, and H, or G and in G and E. Right? So does that mean this would be the optimal solution? Okay? So what happens if you just look at it based on NPV, we would look at the ones with the highest NPV. So that would be 1, 2, 4. Okay, if you looked at like NPV rankings, it would be 1, 2, 4, 2, 3, 4, and 7, 1, 2, 3, 4, and 5, and 6, and 7. Okay, so what happens is that there is a slight error over here. There's no number 5, but this will be NPV rankings if we just look at the positive NPV values. So the issue we have over here is whether or not these NPV rankings are the optimal solution. So what do we do next? Okay, so since we cannot invest in part of a project, we need to use binary constraints in the solver function. Okay, so what does that mean? Okay, so let's bring up the solver. We have data solver is right here. Okay, so let's just minimize that and put it over here. Okay, so what happens is that we use binary constraints in the solver, Ultimately, binary constraints are used in yes or no scenarios where typically yes is a 1 and no equals a 0. And we use the bin constraint in solver. Okay, so binning allows us to inform Excel to change the flag from 0 to 1 to indicate a project is being taken. Okay, so binary constraints allow us to build in various complexities. All right, so let's look at it right now. Okay, so what we can do actually do is actually look at these binary conditions, right? So this is the outcome we're actually looking at, okay? So we have this question over here where invest. So if it's a 1, we invest. If it's a 0, we don't invest. Okay, so that's the ones and zeros are how we use to keep track of which projects we're investing in or not. Okay, so we're going to use funds invested equal to some product, okay, where it's going to be that and what we invest in. Okay, so we're going to multiply. If we're investing in A, then we multiply, and if it's a 1, then it'll become 200,000. If it's a 500,000, this is a 0, then it'll be 0. So we're actually doing a sum product of these two columns. Okay, and we also do a sum product to get the NPV. So we actually understand what is the NPV of the projects that we're investing in. Okay, so only the ones which are a 1 will actually appear down on this chart over here. That's how we set it up. So when we go into the solver, okay, let's see what we have. Okay, we allow it to change E5 to E12. That's the invest column here, right? So we say you can change these variable cells, E5 to E12. We tell it that E5 to E12 have to be binary. That means, okay, it has to be a 1 or a 0. Okay, we tell it that C14, which is the funds invested, must be less than or equal to C2. And we set the objective of D2, actually it's not D2, sorry, it is actually going to be C16 to the maximum. Okay, so then let's reiterate, okay? What is our goal? Our goal is to look at all these different projects from A to H with different net investments and different NPVs. We want to use the solver to tell us which projects that we're going to invest in, which will maximize our NPV, subject to the constraint that the total number of funds invested must be less than $1 million, and where if the choices it can change must be binary, it has to be 0 or 1. You can't go 0.5 or 0.2 or invest partially in a project. You have to go all in, which is 0 or 1. So we set the objective C16 NPV to maximum because we want to maximize NPV. We do this by changing the variable cells invest, which is invest. What is invest has to be binary, 1 or 0. And what happens, the total number of funds invested must be less than $1 million. And that's it. And then we click solve. And there we have it. So let us see what is happening right now. So does that make sense? Okay, so when I click solver, what happens, what I realized was that I had the wrong values in here. So this one is correct. That, my friends, was wrong. Okay, so that was supposed to be D to D. Okay, so what happens, let's do solver again. Okay, so let's click on solve. Okay, now it's given us the right answer, right? Invest in A, invest in C, invest in E and G. Okay, so 10101010. So that's correct, right? So basically that's how the solver function works. So the other things that we probably want to be quite cognizant of, okay, is about with solver, okay, let's see when we actually change it. Okay, make sure the constraint is just type in binary. Okay, alternatively, you can have it as the bin constraint over here as well. Okay, so that's actually how we can actually make sure it's zeros and ones. The other thing to be aware of, okay, is that if we're still having issues, it's giving 0.5, so on and so forth, go to here, go into options, and go with ignore integer constraints. Okay, so basically so far with my example, it's worked perfectly without any issues, but if you are having issues, then go in here, change that to binary bin, or go to here, go to options and say ignore integer constraints, and that should solve your issue. Okay, so that's for question 5. Now let's look at the next example.